In the past couple lessons, we've been looking at polygons, and we've been looking at the attributes and how can we classify them, how can we sort them, how can we put them together. Well, here I've drawn a bunch of different figures. When I look at them, though, the thing about all of them is none of them are actually a polygon. Now, remember, when we look at polygon, we have the word poly, meaning many, and gon, meaning sides. Now, some of these have sides. This one has sides. This one has sides. This has sides. That has a side. But none of them follow the three rules that you have to have for it to be considered a polygon. Now, our three rules is that polygons are made up of straight lines. We call these lines line segments. The sides of a polygon do not cross. When they get to a vertex, they stop. And polygons are closed figures. You can trace their sides and get back to where you started. So if we look, if I was to trace this triangle all the way around, I get back to where I started. If I start here on this hexagon, I can trace it all the way around. That means it's closed. There are no openings, and I can get back to where I began. Nothing crossed. I didn't have to travel anywhere, and everything is straight here. Now, when we're looking at polygons, we want to start looking at their attributes. How many sides do they have? This triangle has 3. This hexagon has 6. Same thing with the vertices. How many do they have? So we're going to take a look at that today, and we're going to be comparing these different things. But first we have to understand that polygons can be irregular. And what I mean by irregular is they don't have to look like we typically see them. So we know a quadrangle or a square normally looks like that. But I can also make a quadrangle like that. It's got 4 sides, it's closed, and everything is straight. A hexagon normally looks like this, but that is also a hexagon. It's got 6 sides, it's closed, everything is straight. We call these types of polygons irregular because they aren't the same length. All sides are not the same, all angles are not the same, everything is a little bit different. That's what makes it irregular. So when we're looking at comparing polygons, we can be looking at comparing a regular polygon, like this square, and this one, like this pentagon. And this one. Now again, these are all polygons. Straight lines, closed, I can trace them around, nothing crosses. But how am I going to compare these? Well, if I'm going to look at these two, I'm going to look for things that are the same. Well, I know they all have 4 sides, 4 vertices, and 4 angles. I'm also going to see that they both have 1 square angle. But now I'm going to look at what is different. Well, this one has all sides the same, while this one has some sides that are different lengths. So I'm going to look at what is the same and what is different. And I'm going to do that with every polygon. So I'm going to go down to my pentagon. I'm going to notice that all these sides are the same. This is a regular pentagon, while this one over here is not regular. Not all sides are the same. We've got this weird inner angle here. We've got this smaller angle here, but it still has 5 sides, 5 vertices. So we're looking at things that are the same and different. So today you're going to get the chance to draw some of your own polygons, and then you're going to compare the difference in them.